Okay, so doing our last section of the Camera Fundamentals 3, and we're going to talk about the raw file format a little bit and why it is great to use over JPEG. Let's hop right in. So, raw file formats. Yeah, what are those exactly? I know I've heard about them. No. So before we talk about what raw file formats are versus, say, JPEGs, which are two most likely choices that we can choose in our camera settings for image quality, for when we're selecting the image quality, is that there's two principal types of visual formats out there. There's pixel-based image, and then there's vector-based images. Pixel-based images means that the image is composed of individual pixel units, and those pixels are made up of red, green, and blue values. So there's a red, green, and blue value for every pixel, and that determines the color of that pixel. And normally think of those as bitmapped images, and it just means that they're almost organized like letters on the page, from left to right, top to bottom. They're coded, and so for every pixel, the image has to be processed and rendered on the screen. So it's a lot of information, but it affords a lot of potentially a lot of resolution. A vector-based image is more of a mathematical based approach. It's very efficient. It doesn't take up nearly as much space, and it's much faster to process. And it is resolution independent. It means it doesn't matter. You can make it as big as you want or as small as you want. It will still have the same sharpness and relative resolution to it. So the advantages of that's another example of that would be like a font face. Um, or a shape file. And so you can make a square or a rectangle or an octagon as big or as small as you want, and you'll still get smooth edges. This is not the case in a pixel-based image. And pixel-based images are what we're capturing when we're using our camera. Okay, and so that's always resolution dependent. And so we always need to be aware of that and make sure that we are doing everything we can to retain the highest quality, and which means also the highest pixel count of our images as we're doing our workflow until the very end. But both JPEGs and RAW file formats, those are both pixel-based or bitmapped images. But what's the difference between these two? Well, why is RAW better? Well, number one, you don't lose any information the camera captures when you're shooting in RAW. The JPEG image is an image that has, once the capture happens and it goes through the analog to digital converter, because the light photons are coming in and hitting the sensor and creating charges, and those charges are then turned into digital information of ones and zeros. But after that happens, the file can be stored as a raw file, or it can be processed on board in the microprocessors of the camera. And when that happens, a lot of decisions are made about um, white balance, the how saturated the image is, how much contrast there is, things like that. And so there's all these presets essentially that are baked into the file, and that'll actually decrease your file often as much by 80%. Remember, JPEG is also a file format that's designed to be space efficient. That's one of the reasons why it was used early on, very much for the internet, because you could put a lot of information in there but still relatively not be too big. And that's because it is it is compressing information in order to be size efficient. So that's kind of at a detriment to us as photographers. We'd like to capture and retain as much detail as possible when we're just capturing. We can make a decision to throw information away when we get to the editing stage, but before that, we want as much as possible generally. Number two, a JPEG is lossy, meaning that it's compressed. A raw file format overall is a lossless file format. It means that you can save it again and again, and you have no loss in image quality. Number three, it has more exposure latitude than a JPEG. This means it can get more information from over and underexposed areas of your image than just a JPEG. Okay, so this means if you didn't get the quite right exposure, you can actually do a little bit more recovery than you could with a JPEG. A JPEG, If you overexpose it or you underexpose it, those blacks or those whites, they're most likely unrecoverable, meaning that you're just going to get blocked up highlights or blocked up dark black, pure black shadows. And lastly, number 4, raw file format. Shooting that way is the beginning of a non-destructive workflow, and we like non-destructive workflows because it means we can go back and forth, change our mind, go up and down. It's more dynamic, and it allows us more latitude and more flexibility when we're editing without having to make any decisions that we can't reverse, right, when we're working and editing the file. So this is the beginning, and that's one of the other reasons. So let's go to that example number 3 case, and we're going to talk about how JPEG is not as good as RAW when we're trying to optimize our image and correct from a possible overexposure. So in this case, you can see on the left, we have a photograph that was taken and it was overexposed to begin with. So the clouds in particular are kind of blocked up white. The highlights in the clouds don't have detail in them, they're just pure white. And we shot this with a JPEG and we shot this in RAW mode. And then we did our best to make this image look good in Adobe Camera Raw. So JPEG optimized in ACR or Adobe Camera Raw, and then down here we're optimized in, the RAW was optimized in Adobe Camera Raw. If you look closely, a couple things that you'll notice is, one, the color is better, like the color in this field is more rich. But if you look like, say, the blue up here, they're pretty similar, right? The other thing, more importantly, is the highlight detail. We were able to recover a fair amount of the highlight detail in the clouds, so that it looks pretty good. It almost can't tell that it was overexposed. But up here in the JPEG, there's large areas of the cloud that are just pure white. There's no information there, and because the image was processed in the camera and those settings were baked into that overexposed file, Adobe Camera Raw or anything else really can't pull out any detail there. So that's a really great reason right there to use RAW all the time. Once you shoot RAW, you can process your RAW files in Adobe Camera Raw plugin, which is part of Photoshop. And you can also do the same thing with your JPEG, so you can still use this as part of your workflow if you shoot in JPEG. But there's not as much as we shed flexibility in your editing. You can't get as much for highlight recovery or shadow enhancement as you can with the RAW file because the information is just simply not there. Going a little bit deeper into a digital capture, we have to think about distinctions between the way it works versus the way our eyes work and the way film works. So a digital capture is linear by nature, whereas film is logarithmic. And that's important for us for a couple of reasons. I'm going to read this, I'm going to excerpt. So it says, if you inspected the images your camera captured as RAW files, they would look something like the image shown in the top left. Notice that the image is very dark. It's lacking in contrast, and the levels representing the tonal information in the histogram below it appear to be mostly bunched up to the left. During the RAW conversion process, a gamma curve correction is applied when converting the linear data so that the processed image matches the way we are used to viewing the relative brightness in a scene. The picture top right shows the same image after a basic RAW conversion. And this RAW conversion is something that you don't see. It's not something that happens in Adobe Camera Raw. It's something that happens behind the scenes. A consequence of this is that the more brightly exposed areas will preserve the most tonal information, and the shadow areas will end up with fewer levels. A typical CCD sensor, this is sort of similar to a CMOS sensor, which most digital cameras use now. But a typical CCD sensor can capture up to 4,996 levels of tonal information. Half these levels will be recorded in the brightest stop exposure range, and the recorded levels are effectively halved with every stop decrease in exposure. Now that's a little bit complicated to unpack, but I'll show you what that means in the next slide. The digital camera exposure is therefore quite critical. Ideally, you want the exposure to be as bright as possible so that you make full use of the levels histogram, but at the same time, be careful to make sure the highlights don't get clipped. Okay, and so let's look at what he means by that a little bit. That's an excerpt from Martin Evening. So here we've got the raw golden rule: expose as bright as possible without clipping. And so what he means by that is if there's 4,096 possible tonal values in a 12-bit raw file. Now that actual number of tonal values is going to be dependent on your camera. A really high-end camera may have more like a 14-bit or possibly even 16-bit raw file, meaning that there would be more tonal values. But if we assume this, we say what he's saying is for those 4,000 tonal values, imagine a grayscale in the simplest terms, 0 being black and 4,096 being pure white. What he's saying is in the first stop of exposure between pure white and one stop down, so like a light gray, half of those tonal values are going to be attributed just to that region. And then as you go down into the second stop and the third stop, the amount of tonal value information that is spread out across these kind of the middle tonal ranges keep going down to the point when you get to the last and the darkest part of your image, you have only 128 or a fraction of the total tonal values possible in those shadows. And it just means if more of your information is in those darker regions, then it's going to be harder and you will not have as much digital capacity to edit that image without it starting to look bad. It's not something that you have to stress over a lot, but it is something to be aware of. If you had to make a decision, you'd rather overexpose a little bit and make a scene a little bit brighter, even if you want to edit it and make it darker in the final version when you're editing it. But you want to make sure that you're not going to do something like this, which is getting clipping in the highlights. If you're clipping in the highlights, that means that histogram is getting ramped up along the right edge, okay? And clipping in highlights is not good because that means there's no tonal value. Now a camera, if it's starting to flash like this, it's showing you're very close to clipping or you are clipping. So just a little bit of this would be okay, but you can see here, this is a little overexposed image altogether. And so this is the scenario you do want to avoid. You don't want to overexpose quite this much. And here is just the same image, but it's been shown to us with the histogram now, and you can see how that ramp up is going on in that highlighted region on the right, and that is that shows you that that's where that clipping is occurring in the ocean foam, and do be careful of that. So use raw. It is larger, but most of us have a large amount of room to store our files in, so it's not a good time to waste quality to conserve space. You want the best quality possible. Okay. All right, good. Hope you enjoyed these lessons and they are very useful to you.